Okay, hello everyone. For this session, we're going to talk about how to get the molar mass, how to get the percentage composition, and from percentage composition, we're going to get the empirical formula and molecular formula of the compound. Okay, so what do you know of molar mass? So molar mass is expressed in grams per mole. This is the mass obtained as the sum of the product of the atomic masses and the number of atoms of every element that comprise the compound. So after learning how to write the chemical formula of the compound, we are to get the molar mass or the mass per mole of the compound, and this is expressed in grams per mole. So in getting the molar mass, for an atom, the mass per mole is simply equivalent to the atomic mass of that element in atomic mass unit or in grams per mole. So meaning to say, for every 1 mole of the element, its mass or molar mass will be equivalent to its atomic mass. Say, for example, if you have the element carbon, so what is the mass of 1 mole of carbon? So since carbon has a mass of 12 grams per mole, so for every 1 mole of carbon, that will represent its molar mass. So say, for example, for the element or for the atom sodium, what will be the molar mass of the element sodium? So since sodium has a mass of 22.99, its mass or grams per mole is 22.99. So for an element or for an atom, there will be no problem in determining the molar mass, because whatever its is atomic mass in the periodic table, in atomic mass unit, that will also represent its atomic mass. What about for the compound? So for the compound, the molar mass is taken by simply getting the mass, total mass of the atom in a compound. Say, for example, if we have aluminum hydroxide, so its chemical formula is Al, and then open parenthesis, then OH, then close parenthesis 3. So that is its chemical formula. So if you are to check the chemical formula and count how many atoms of each, how many atoms are present in the compound, what are the elements, and how many are these elements in the compound. So for aluminum, there is 1 aluminum atom in aluminum hydroxide, and its atomic weight or atomic mass is 26.98. For oxygen, how many oxygen atom are found in aluminum hydroxide? So there are 3, and you multiply that to the atomic mass of oxygen, and that is 15.99. And for hydrogen, obviously, how many atoms of hydrogen are present in aluminum hydroxide? It's also 3. And you multiply it to the atomic mass of hydrogen, and that is 1.00. So getting the sum of these elements will give 77.95 grams per mole. So meaning to say, for every 1 mole of aluminum hydroxide, it will weigh 77.95. So that's how to get molar mass for the compound. Say, for example, for sodium chloride, So in the formula or chemical formula of sodium chloride, you have 1 sodium and 1 chlorine. And you multiply this ratio to the atomic weight of each element, and we have 22.99 and 35.45. So adding or getting the sum of the mass of the elements will have 58.44 grams per mole. So that is the molar mass for sodium chloride. Okay. Also for calcium phosphate, take a look at the chemical formula. So you check how many atoms of calcium, of phosphorus, and oxygen are in calcium phosphate. Then you simply check the atomic weight of the element in the periodic table and get the sum of the atomic mass of this element. So for the mass of calcium, you have 40.08, and then you multiply to 3. Then add to that 2 multiplied by the atomic weight of phosphorus, which is 30.97. And then for oxygen, you have 16. You multiply it to 8 and then add. So the molar mass in grams per mole of calcium phosphate is 310.18. So that's how to get the molar mass. Okay? So this time, we'll be moving on to percent composition. So when we say percent composition, we are getting the percentages, the part of the components in a compound. A while ago, we had analyzed what are the elements that compose a compound. This time, we'll check the percentage of this element in a compound. So percent composition is simply calculated by dividing the mass of the component over the total mass of the compound, and we multiply to 100, because percent composition is simply the mass of each element in a compound compared to the intermass of the compound. So after getting the molar mass, we can possibly get the percent composition of the elements in the compound by applying the formula mass of the component over the total mass of the compound, and we multiply to 100. So using the same example a while ago for aluminum hydroxide. So we had presented that the molar mass of aluminum hydroxide is 77.95 grams per mole. So if you are asked to find the percent composition, so take note what compose aluminum hydroxide. So you will find in the chemical formula aluminum, oxygen, and hydrogen. So what is the percentage of each component to the compound? So by applying mass of the component over the total mass of the compound, multiply to 100. So for percentage of aluminum, so aluminum is 26.98 grams per mole in the compound. You divide it to the total mass of 77.95 and multiply to 100. So the percent composition of aluminum is 34.61. So same with oxygen. So you will see that oxygen comprise 47.97 grams per mole in the compound. You divide it to the total of 77.95 and multiply to 100, so you will obtain 61.54%. And of course, for hydrogen is 3 grams per mole, divide 77.95 grams per mole and multiply to 100, and there you have 3.85. So this is what is meant by percent composition. So in the entire compound for aluminum hydroxide, the percent composition of aluminum is 34.61, oxygen is 61.54, and the hydrogen is 3.85. And take note, when you add these percentages, the sum is 100. So adding 34.61, 61.54, and 3.85, the sum is 100. Okay, so this is how to get the percent composition. Same with sodium chloride. We had computed a while ago how to get the molar mass. So in getting the percent composition, what will you do? Okay, so you have for sodium, it's 22.99 divided the total mass or the molar mass of 58.44, then multiply to 100. Same with chlorine, 35.45, you divide it to 58.44 and then multiply it to 100. So our percentages or percent composition for sodium and chlorine, 39.34% and 60.66%. So meaning to say, for every 1 mole of sodium chloride, this will be the percent composition of sodium and chlorine. And adding 39.34 and 60.66, we have 100%. Okay? So same with calcium phosphate, the one that was given a while ago. So the molar mass is 310.18. What are the composition of calcium phosphate? So we have calcium, phosphorus, and oxygen. So to get the percent composition of each, you apply the formula. So you have for calcium 120.24 divided by 310.18 and phosphorus 61.94 divided by 310.18 and 128 divided by 310.18 times 100. So these are the percent composition for calcium, phosphorus, and oxygen. Okay? Okay, next. So with percent composition, that will help identify compounds empirical formula. So for chemists who found an unknown compound and by analysis, and they were able to get the percent composition of each element, they can possibly identify the compound's empirical formula and compound's molecular formula. So what is the meaning of empirical formula of the compound and molecular formula of the compound? Okay, so for empirical formula, this is simply the relative number of each type of atom in a compound. And this is the formula with the smallest whole number mole ratio of the element. Again, empirical is the formula that gives the relative number of each type of atom in a compound. And this is the formula with the smallest whole number mole ratio of the elements. Molecular formula, on the other hand, gives the actual number of each type of atom in a molecule of a compound. And this is a whole number multiple of empirical formula. So molecular formula is the actual number or gives the actual number of each type of atom in a molecule. And this is simply the multiple or whole number multiple of empirical formula. Okay, so you look at the table. Here you will see the difference between empirical and molecular. Okay, so if you will notice, say for example, okay, for water, it has the same empirical and molecular formula. So there were times that you will encounter when you are trying to compute or calculate the empirical formula, there are possibilities that empirical formula is also the molecular formula. So in the case of water, the actual number of the hydrogen and oxygen in a compound is 2:1. Because that is the simplest ratio, its empirical is also H2O. But when you look at the hydrogen peroxide or agua oxinada, its actual or molecular formula is H2O2. But looking at the ratio of hydrogen and oxygen, which is 2:2, that's not the simplest, smallest whole number ratio, but we can simplify it to 1:1, and therefore its empirical is HO. Okay, same as with benzene. So its true formula or actual number of atoms in a compound is 6:6, but we can still simplify this to CEH for 1:1. That is its empirical. Similar to glucose, look at glucose. Glucose, the actual number of carbon, hydrogen, and oxygen is 6:12:6. But because these are divisible by 6, its empirical is 1:2:1. Therefore, its empirical is CH2O. So with that, it's very clear that the molecular is simply the multiple of empirical. Okay? So you look at the multiples here. So for the first example, you'll have here 2 as the multiple of nitrogen and hydrogen, and the actual ratio of nitrogen and hydrogen in hydrazine is 2:4. And from the example a while ago of glucose, where the multiple is 6, and then its actual formula or actual number is C6H12O6. So that's the difference between empirical and molecular. Now, from percent composition, how can we determine the empirical formula of the compound? Given these steps, okay, so there are 4 basic steps that you need to apply in determining the empirical formula from percent composition. First, you have to assume that you have a 100-gram sample. So this will allow you to translate the mass percent of each element directly into grams. So the given percentages will be converted to mass in gram. And number 2, you get the number of moles. Take note, in getting the mole, you apply the formula given mass divided by the molar mass. Take note of the molar mass. Molar mass is the mass in an atom, is simply the mass in grams of 1 moles of an element. In a compound, it's simply the summation of the atomic mass of atoms in a compound. Okay? Again, so okay, we'll move on to step 3, get the mole ratio. So that mole ratio is taken by simply applying the formula moles of each element. So after computing the mole, so mole of each element, you divide it to the moles of the element with the smallest amount. And the last one, that mole ratio will be used as subscript. But in case that the ratio is not a whole number, multiply all the ratios by the smallest possible whole number that will give, or that will produce a whole number ratio. Because in a chemical formula, there is no such thing as decimal subscript. So if in case that you will come up with a decimal number, you need to multiply that to the smallest number that will make the subscript a whole number. Okay? So again, in determining the empirical formula first, the percentage composition of each element is converted into mass in gram. The second is you get the mole by applying the formula mass over the molar mass. The third is to get the mole ratio. how the mole of each element divided by the moles of the element with the smallest amount, and then use that mole ratio as the subscript to determine the empirical formula. Say, for example, if you have this problem, metal acetate, this is commonly used as solvent in paint, ink, and adhesive. So given 48.64% carbon, 8.16% hydrogen, and 43.20% oxygen, what is the compound's empirical formula? So take note, you will see percent composition in the problem. So first is you have to convert these percentages into mass in gram. So you simply have carbon 48.64 gram, hydrogen 8.16 gram, and oxygen 43.20 grams. So we assume that the sample is 100 gram. After that, you get the number of moles. How? So mass of the carbon divided by its atomic mass, which is 12.01. Hydrogen is 8.16 divided 1, and oxygen is 43.20. In the periodic table is 15.99 or 16. So the mole for each element is 4.05, 8.16, and 2.70. So how will you get the mole ratio? You choose the smallest mole, and that is 2.70. So divide each mole to the smallest mole for you to get the mole ratio. So the ratio is 1.5, 3, and 1. So since there is no such compound as C1.5, H3O, you have to multiply the mole to the smallest whole number that will give you a whole number subscript, and that is 2. So 1.5 by 2 is 3, 3 by 2 is 6, and 1 times 2 is 2. So the ratio of carbon, hydrogen, and oxygen is 3 is to 6 is to 2. So what is its empirical? C3H6O2. So that solvent used in paint, ink, and adhesive has an empirical formula of C3H6O2. So that's the simplest, because you can't simplify 3 is to 6 is to 2. Okay? So let's have another example. Say you have a compound where it consists of calcium. So this is already in mass in gram. Calcium 13.5 grams, oxygen 10.8, and hydrogen 675,000 grams. What is the compound's empirical? So take a look at the given. It's already in mass in gram. Then get the mole. So the mass of calcium will be divided, the given mass will be divided to the molar mass. Same with oxygen, 10.8 grams divided by the molar mass of oxygen. And also for hydrogen, you divide it to 1, 0.675 divided 1. And these are the moles. So we have 0.337 mole, 0.675 mole, and 0.668 mole. So what's the smallest mole here? Okay, so that is 0.337. So that will be our divisor. So to get the mole ratio, divide each mole with the smallest. So for calcium, you have 1, oxygen, you have 2, and hydrogen, you have 1.98. So you have to round it off to 2. So what's the ratio now? What is the empirical formula? If calcium is 1, oxygen is 2, and hydrogen is 2, so we have CaO2H2. That's correct. So we have calcium hydroxide. So that's the empirical formula of the compound. Okay, you have question? Okay, this time we'll be moving on to determining the molecular formula. Take note, when we say molecular formula, this is the actual number of an atom in a compound. Okay, so this is a multiple of the empirical formula. So for getting the molecular formula, we are to follow the steps for finding the empirical formula. But this time, we need to know how many EFU or empirical formula unit that make up the molecular formula. To find the EFU, so the given molecular mass, you divide it to the empirical formula mass. Okay? So after finding the empirical formula, you will get the empirical formula mass because you will use that in finding the empirical formula unit or the EFU. So in determining the molecular formula, you will see that in the problem, there is an additional given, and that is the molecular mass of the compound. So caffeine, I'm sure you're very particular about caffeine. Caffeine is a chemical found in coffee and in tea. Okay? And its composition is 49.5 carbon, 5.20% of hydrogen, 28.8% of nitrogen, and oxygen 16.5%. So if the molecular mass of caffeine is 194.1 gram per mole, what is the compound's or what is caffeine's molecular formula? So again, we'll start first with finding the empirical formula. So from the steps we apply in finding the empirical. So first we convert the percent into mass in gram. Okay? To get the mole, you divide the mass in gram into its atomic mass in gram per mole. Molar mass rather. So for carbon, you have 12.01 and so on. So the mole here is 4.12, 5.20, 2.06, and 1.03. And what is the smallest mole here? So we have 1.03. So divide all the mole with the smallest mole to get the ratio. And after dividing it with 1.03, the ratio of carbon, hydrogen, nitrogen, and oxygen is 4:5:2:1. Therefore, its empirical formula is C4H5N2O. So we'll not stop there because that is just the empirical formula of the compound. So to continue, how are we going to get the EFU or the empirical formula unit? This time, we need to get first the empirical formula mass. So a while ago, the empirical that was computed is C4H5N2O. So to get the total mass of that or the empirical formula mass, so 4 multiplied by 12.01. So we will apply how to get the molar mass. So the total mass of the compound or the empirical formula mass is 97.03 gram per mole. How are we going to get the EFU? Take note in getting the EFU, it's the molecular mass divided by the empirical formula mass. Okay? So in the problem, our molecular mass is 194.1 gram per mole and the empirical formula mass is 97.03 and the EFU is 2. So this is the multiple of the empirical. How are we going to get the empirical formula? So from the empirical formula times the EFU, which is 2. So empirical formula, which is C4H5N2O, you multiply it to 2. And therefore, you have CH10N4O2. That is the caffeine's molecular formula. So you see, in getting the molecular, After finding the empirical, you need to get the EFU. How? Get the empirical formula mass of the empirical formula, and then from the molecular mass, you divide the empirical formula mass, so you get the empirical formula unit, and that is 2. You multiply that to the empirical for you to get the molecular formula. Okay, clear? Okay, let's have the last example. NutraSweet. I understand that this is very common to you because you mostly check this from the many beverages that you are buying from the supermarket. So what is the molecular formula of NutraSweet? Given 57.14% of carbon, 6.16% of hydrogen, 9.52% of nitrogen, and 27.18% of oxygen. What is the compound's molecular formula if the molecular mass is 294.30? So take note of the molecular mass is 294.30 grams per mole. So given in mass in grams, so the percentage will be converted to mass in gram. And then get the mole by applying mass or given mass divided by the molar mass. So you check the molar mass of each element in the periodic table. Okay, so after getting the mole, you choose the smallest. So from the list, the smallest is 6,800 mole of nitrogen. So to get the mole ratio, you divide all the moles with the smallest mole, and that is 0.68. And therefore, the ratio is 7:9:1:2.5. Again, take note, we cannot use 2.5 as a subscript in a compound. So what are you going to do? Okay, correct. You multiply that to the smallest possible number that will give the smallest whole number ratio, and that is 2. Correct. So again, 7, 9, 1, and 2.5. You multiply this to 2. And therefore, you have the ratio of 14, 18, 2, and 5. So can we now use that as a subscript? Okay, very good. So you can use that. Therefore, the empirical formula for NutraSweet is C14, H18, N2O5. Okay? How will you get now the molecular formula? So again, in getting the molecular, you need to get the EFU or empirical formula unit. After getting the empirical formula, you need to calculate the molar mass or the empirical formula mass of C14, H18, and 2O5. And that is 294 grams per mole. How will you get the EFU? The molecular mass over the empirical formula mass. So 294, the molecular mass of the NutraSweet, you divide it to the empirical formula of 294, and therefore the EFU is 1. So what is the NutraSweet's molecular formula? Okay, so they're just the same. Take note, empirical formula of the compound can also be a molecular formula. So since the EFU is 1, therefore, the molecular formula is similar to the empirical, or empirical formula is the same with the molecular formula. Okay, question? Okay, so thank you for listening. See you on our next session. Bye-bye.